Very good morning to all. I am Dr. R. Udayakumar, Professor and Dean, Department of Computer Science Engineering and Information Technology of Kalinga University, Naya Raipur, India. Here I am going to share the core content of computer organization and architecture. For each and every subject, an objective is required to make the student to understand the core content of the syllabus. Here the objectives are: the primary objective of this course is to make student to understand organization of computer, which includes knowledge about the computer memory and different functional units. Next, we see about the outcomes of this subject. What are all the outcomes received by the students for this subject? The first point is study of the basic structure and operation of digital computer system. Second point is analysis of the design of arithmetic and logic unit and understanding of the fixed point and floating point arithmetic operations. Third point, implementation of control unit techniques and the concept of the pipeline. The core content is classified as the points. Here I explain the core content. Functional unit of digital system and their interconnections. Next, buses. Next is bus architecture. Next, types of buses and bus arbitration. Next is register. Next is bus and memory transfer. Next, processor organization. Next, general register organization, stack organization and addressing modes. Now we saw the functional unit. What is functional unit? How the functional unit perform in the subject of computer organization and architecture. A computer can process data, pictures, sound and graphics. They can solve highly complicated problems and give the solutions quickly and accurately. It accepts data or instruction by way of input. It stores the data. It can process data as required by the user. It gives results in the form of output. It controls all operations inside a computer. The next we are explaining about the functional unit of the computer organization and architecture. Here we are the functional unit is categorized in 5. First one is the input unit, next one is the storage unit, next one is the output unit. In the storage unit we have another 2 units, control unit and arithmetic and logic units. This control unit and arithmetic and logic unit is named as the central processing unit. So here we give the programs or the data as the input and it travels to the storage unit. From the storage unit it is submitted for the processing the arithmetic and logic operations or control, then again back to the storage unit. From there it is forwarded to the output unit to get the results. The core area of the functional unit is 3 types: processing, output and control. Let us see the functions of the processing, output and control. Now, processing. The task of performing operations like arithmetic and logic operations is called processing. The central processing unit, CPU, takes the data and the instructions from the storage unit and make all the sort of calculations based on the instructions given and the type of data provided. Next one is the output. This is the process of producing results from the data for getting useful information. Similarly, the output produced by the computer after processing must also be kept somewhere inside the computer before being given to you in human readable form. Again, the output is also stored inside the computer for further processing. Next is the control. The manner how the instructions are executed and the above operations are performed. Controlling of all the operations like input, processing and output are performed by the control unit. Next, we saw about the bus and its architecture. A bus is a connection between components or devices connected to a computer. The bus connection contains multiple wires called as the signal lines with addressing information describing the memory location of where the data is being stored or retrieved. Core functions of buses in the computers are data sharing, addressing, power and timing. Bus and its architecture can be defined in the three parts. One is CPU, memory and input and output unit. A bus transfers electrical signal from one place to another. An actual bus appears as an endless amount of edged copper circuits on the motherboard surface. The bus is connected to CPU through the bus interface. Data travels between the CPU and memory along the data bus. The location called as the address of the data is carried along the address bus. A clock signal which happens everything synchronized travels along the control bus. Here we see the types of buses. Number one is the control bus, next one is the data bus and next one is the address bus. Here we see the explanation of the control bus. The motherboard's control bus manages the activity in the system. The data bus acts as a conduit for data from the keyboard, memory and other devices. It passes information at speed up to billions of characters per second. Next one is the address bus. The computer must be able to access every character of memory rapidly, so every character has its own address number. The central processor specifies which addresses it wants to read or write, and the address bus carries the information to a memory controller circuit which locates and fetches the information. Next, we saw the roles of register in the computer organization and architecture. How the register transfer the information from one register to another register is designated in the symbolic form by means of a replacement operator. The statements of denotes a transfer of the content R2. Transfer the data from R1, register R1 into register R2. It designates a replacement of the content of R2 by the content of R1. By definition, the content of the source register R1 does not change after the transfer.